Okay, this is a short worked exercise about the binomial distribution. We should get through it fairly quickly. It is really short, but I will include it just to have the full list of questions from the exam paper in a playlist rather than having this as a conspicuous absence. So, a child tosses n coins, and the outcomes of the experiment, the coin toss experiment, is heads or tails, and the outcomes are recorded in n samples as x1, x2, all the way up to xn, where xi are independent Bernoulli variables with probability equals p equals 0.5. The total outcome of n variables is the summation of those, y equals x1 plus x2, all the way up to xn. Okay, so one of the heads or tails, one of them is chosen as a success, and we're counting the number of successes. Use n equals 10 unless told otherwise. This was oversight in the question that this is drawn from, that there was no specification of what number to use for the sample size, so we will just use n equals 10 as suggested in the solutions. So the exercises are as follows. Specify the distribution of y. Okay, that's exercise A. B, simulate a sample of 10 values for y. Okay. C, assess the value of y for the sample created in exercise B. And D, what is the probability of y equal to 4? Okay. So, if x1, x2, all the way up to xn follow a Bernoulli distribution with p equals 0.5, then y follows a binomial distribution. Y is a binomial with parameters n and p. N is the number of trials. P is the probability of success. That is the sum of independent Bernoulli trials results in binomial distribution form, aka binomial with n trials or n trials, and p equals the probability of success. Okay, so it's a binomial distribution. Okay, so the answer below is calculated using n equal to 10. So we're going to set up n equal to 10 and p equals 0.5. Okay, and we're going to generate 10 random numbers distributed according to that distribution, where n is also 10. 10 numbers from, and the sample size or the number of trials is 10, and the probability of success is 10. So here is our little data set here. So the first one is y. The first value is 7. That means there was 7 successes out of 10 trials. Five successes out of 10 trials, and so on. Okay, so that's the answer to part B. That's how we set up a little binomial data set that is distributed with n equal 5 and p equals 0.5. N equal 10 and p equals 0.5. Okay, the value simulated in exercise B are represented values of variable y itself. No further calculation is required to assess the value of the variable y. Strange question, to be honest with you. I don't think this exam question was well written, but we'll go through it anyway. And we're asked for the probability of y equal to 4. So essentially what we're going to use here is d binom. This creates the density function. Okay. And we can use this to create the probability mass function for all values of all possible values of y. Anyway, here d binom, d is for density, binom is for binomial distribution. Y equals 4, so we have the 4 there. N equals the 10, the size equals n, the number of trials, and p is the probability of success, so it is 0.205. So that's it. We'll leave that one there. It's a short one.